Now, one of the things that we do that's kind of, yeah. So make sure you all have out, before we get into the notes for the day, on the yellow calculators that you all picked up, raise your hand if you've had one of these. You've used the navigator calculators before where you've had to log in. 3 of you? 2, 3 of you? Most of you are a no? Okay, fabulous. What we're going to have you do is this, so we're all on the same page. The first thing that you're going to do is make sure that your calculator is on and you're on the home screen. So everybody should be looking at that black home screen. Once you're on there, and this is what you're going to do every day, you're going to log into the calculator. You hit 5 and then 5 to log in. And now, you all have an individual username. The username that you have is the first letter of your first name and then your last name. So Bob Smith is B. Smith, and your password, this is very difficult, you're going to struggle to remember, is 1, 2, 3, 4. Somebody, I said in the other testament you might want to write that down if you were actually writing it down. It's 1, 2, 3, 4. That's it. As you do it, you're going to see that your name goes from gray to black. That means that you've successfully logged in. Now, the reason that we do this is, and I always laugh, I will freely acknowledge there are a lot of times where I am very, very lazy. And I'm not good with the Chromebook computers that much. I'm good with this computer unless anything changes on it. And I'm terrible at these calculators. But they're also profoundly amazing with what they can do, and you all are very good at them. So, as soon as by the way, is there anybody that it didn't work for? Yes. What's your name? Okay, so you're TWINN. Is that right? Is it not letting you log in? Yes, perfect. Now, some of you are going to have this error come up sporadically because these calculators are used constantly. See right now how the login on his screen was grayed out, okay? Turn it over on the back. There's this little reset button, which is like the hard reset on the computer. You don't need to press it now because then you have to go through and re-log in, but you're going to need to. If you're ever locked out from logging in, you just need to do a hard reset on it by doing that, and then it'll reboot. It takes 2 seconds, and then you can log in, okay? The reason, though, that we have you do and use these calculators, there's 2 reasons, really. One of them is this. So as of right now, I can see every single one of your calculators live. The other thing that's really cool is I can actually, and it refreshes, so you can go into the home screen and I can see, 1 or 2 people. I can make sure that you're with us or not with us. The other thing that we can do is, I'll take one, let's say this. Go in, please, to the home screen. So go back to the home button if you're not there automatically. This doesn't matter for this year, but you're going to want to make a, by the way, you don't ever store documents on here. Some people have, it causes like memory issues or something. Go up to new document as opposed to working in the scratch pad. The reason that I say that is that when you work in Scratchpad, the stuff is easily erasable. So go in right now, go into new document, let's do like a calculation one, add calculator, right? And you go in and type in like 2 + 2 or something like that, and it's yours. You own that. Oh, by the way, another thing, so press enter on that. Another thing that we do, and I hope the reason that I'm doing this is, so when I have you in calculus, I'm not having to re-explain these things all the time. If you operate in this section, the document section, as opposed to the Scratchpad, I'll show you what I do to the people that operate in Scratchpad in a second. But this allows, you're going to have to store values when you take calculus. Like you'll find where 2 graphs cross, you need to store the exact value. If you're in Scratchpad, you can't store values because Scratchpad is easily erased. And the documents, it saves it locally. It's like actually working in the computer part of it. Go in right now. I think it's under Doc. So if you press that, go down to 7 for settings and status. And then document settings, which is 2. It's a little bit longer to get to these menu options, but there's also a little bit of reward for it, and I'll show you what that reward is in a second. You need to make sure this is the first year we're going to be tinkering and screwing around with degrees or ratings, and you need to know whether to bounce back and forth between those. But the other thing is this float. You always need to make sure it's showing as many digits as possible. This calculator goes really far out, but if you have it like float 2, it's going to truncate your answer at 2 digits. So let's go back now to our home screen. So that's why we operate in the doc settings when we use them. Go back to your home screen right now and go over to calculate in Scratchpad, so press A. And now, you all have some stuff in there, right? So let's do this. We'll stop presenter. And by the way, to make it even more embarrassing, we can go through and say this is whose calculator is doing what right now. So, so if people aren't paying attention sporadically, I'll just highlight their calculator and then we'll wait for that one person. But in any case, go over to Scratchpad right now and just start, put in, 2 times 5, plug in like 3 or 4 entries. So go through and do that right now. If there's entries in there, you don't even have to do anything. Because the one thing that I love to do, and I do this during the second calc test, I always do this because I try to make it very clear. The document settings is terrific. I won't do this to you maybe during the test if I want to really throw you a curveball. But in any case, so we've all got some stuff in there, and if you're working in Scratchpad, one of the things that I can do, I don't know why they would think that this is a useful feature, but what I can do right now is every one of you should have just had your Scratchpad completely clear. Okay? Now, for the calculus students, I love doing it because they're in the middle of the test, we're really focused, and if I say don't use the Scratchpad, and you're using Scratchpad, what happened to all of your work? It's gone. Go back to your documents, please. Go back, and I think, and you all, again, are probably way better at this than I, but if you go back to the document, go back to the one that you were on, and is the stuff that you had still there? Yeah. No. Some of you had cleared it out. Oh, you might have done a new document. Okay? If you went back to the document that you were working on, it wouldn't affect it. But that's one thing, maybe one or two times during the year just to mess with you. Maybe on an assessment, right when you're panicking, I'll go through and clear out all your work. But in any case, so that's why we do what we do. And have you use those calculators. So I can see, I also use it to take attendance a lot of times in the beginning of the year. They're really, really good calculators. The other benefit is, these, when you have them, in general, I hate to ruin it for you. Well, the reason that I bring it up is because I've had calculators from my room stolen, and I didn't even know. And it was somebody from Webster Police. There was a pawn shop on Lake Avenue where a bunch of calculators had shown up, and my name, they erased it on 6 of them, on 2 of them, but there was one that I had that said McAtee 6, and they Googled who I was through a New York State employee database, found out that it was a school, because these yellow ones, they school property on them, and they still tried to pawn them. Somebody gave them money for them, but whatever. If somebody takes these, you can't, these ones that are yellow are very difficult to unload if somebody's trying to steal them and sell them for money. Especially not only because they have my name on them that comes out with rubbing alcohol, because they're yellow. These ones like this, I would advise you, this is me being always thinking of the worst case scenario, people steal these, and you will find it on eBay. You can buy a reused one. We had somebody one year that bought one bought one with the kid's last name on it, bought it through eBay for their child in Arizona, got it, found out that the kid was from Webster, New York State, must have had a very unique name, emailed somebody from Webster, the person that was listed as a math department chair, and they actually mailed the calculator back. They felt so bad that they had bought something that was stolen. People will steal these, and it's like, you've got, is it carved in there? Yeah. I would carve it in, because markers come off with rubbing alcohol, and even with that, are people really going to be able to tell that it's, unless they're really looking at it? People have sticky fingers. This sells for like $80 or $90, and people will literally leave them in here and walk away. and that's why I'd rather you have them at home. And the computers, they'll give you like a new one if somebody walks away with it. These ones, this is yours. It's 80 or 90 bucks. You don't want to mess around with it. That's why I say leave them at home. You will always have that class set here unless I tell you otherwise. So you can leave your calculators at home if you have them, but I'd expect that you'd use them on your homework. Now, we left off last time. Where did we go? How far did we go out? Let's handle this first. Bounce over, please, to page 1. We're down to example 3. Did we get through 1 and 2 last time? Is that right? Okay, terrific. Now, we talked before, in our first couple of days, we're going to focus on factors. Now, we went through and did greatest common factor the other day. We're going to do another way to do greatest common factor. It's not difficult if you keep in mind what a GCF is. And a greatest common factor is something that you're dividing out, something that both terms of a binomial are going to have in common, and all you're doing is dividing that out. When I look at A, I see this big picture here is a big binomial. Binomials have terms separated by addition and subtraction. This is the left half of the binomial, and this is the right half of the binomial. Within the big binomial, this has binomial factors as well. Now, looking at what's there, looking at the big binomial, is there something common from the left and the right side? The answer should be a yes. Hands up, please, if you can tell me in 1A what the left and right half of the binomial share. And it's what's common, what factor you can divide out from both of them. We got 2 people. What do you want to say? More than that.
X minus 5.
The quantity x minus 5. Now, what we're going to do when you're taking a GCF, I'm going to rewrite this. I'm going to factor out the x minus 5. When you take out a GCF, what you're really doing is telling me what's left over after I divide this out. Now, I don't need you to show that out, but that's actually what's happening. You're just going through and you're dividing out. So when I look at this, I'm dividing out the x minus 5 from both sides. On the left side, I would be left with quantity x plus 6. So I list that out. Remember, brackets are just secondary parentheses. Then I've got a plus sign there. Now on the right side, I'm also going to have to divide out the x minus 5. And again, understand the word common means that everything has it, not just some of it. So we're going to divide out the common factor that leaves me with 2x plus 5. Now I look and say, well, what more can I do? Can this keep going? Is there else that we can do to make this simpler or go further? And looking at it, there should be. One thing that you all should know, especially as Enriched kids, what's the coefficient in front of both of those? A 1. So if we distribute out a 1, you're left with essentially this. So we can drop the parentheses at this point. Do those 4 terms in the second set of parentheses, do they simplify down? Absolutely. Hands up, please, if you can tell me what you'd be left with on the right-hand side. You condense it. And what are you going to have in front of that 3x plus 11? There you go. There you go. How about for question B? Hands up, please, if you can tell me the GCF or what's common to both sides. We can divide out. We'll wait for 6 of us. We've got 1 so far. 2, 3, 4, 5. What do you want to say? The quantity m plus n being squared. Now when you take out an m plus n squared, hands up please if you can tell me what's going to remain. Hands up please if you can tell me what's left after I factor out the quantity m plus n being squared. 4 and 5? What do you want to say? There you go. There's no more like terms that we can put together. That's it. This next one is probably one of the 2 or 3 toughest ones that we do today. There's a lot of steps to it, and we keep going and going and going. Let's start off with the easy part. Is there a greatest common factor? So that's going to be a big yes. Hands up, please, when you can tell me what the GCF What can you factor out from the left and the right side? Would you like to say? Now, I'm going to use brackets there. If you need to show the division on your paper, that's terrific. That's fine. I don't care. Just make sure, please, that you go through and you're getting your answers right. What's left after I divide out the quantity r plus 2s being squared from both sides? Hands up, please, when you can tell me what you would be left with when you divide out an r plus 2s squared from both sides. We got 2 of us so far. 3. We're getting there. What would you like to say?
P minus 2.
Close. Close. You can tell me the one part from there that's missing? R plus s to the first is going to be left as well, because you took out a square and that one's cubed. So, I do need the parentheses there, and I get to that point. And we were great with not losing the negative. Now, the next thing I asked is, can we go further? And as we told you the other day, I'm a pusher. Of course we can. Hands up, please, and tell me what we can do to make this, what more we can do like that. What algebra can we do? Don't overthink it. And there's, by the way, there's no new math operations this year. We're still add, subtract, multiply. Really? Okay. Close, not factor. Times we can distribute. Yeah, distribute. But that negative q needs to get dropped out and multiplied out. So when I do that, I'm going to say it's p minus qr minus 2qs. But distribute it out. Take it as far as it'll go, because you never know. Maybe there's a chance for like terms that can be put together. Now, on question D, D is actually simple, but there's so much that goes on it because you have to keep going and going and going. This is a perfect push-to question. Go through right now. I'm going to give you a 30-second head start on question D. Do the math. Trust your process. We're not working even with big numbers here. Sorry for the lack of space. Looking at what's there, let's start off with this. Hands up, please, if you can tell me what the GCF is.
P minus 1.
And what are you left with when you take out that P minus 5?
P plus 2 minus 3 and plus 4.
Now, the only thing I'd say to tighten that thing, and again, I get irritated with the teachers that you've had previously because they don't make you, I hear things like as I'm walking through the hall, and they go, oh, it's the top of the fraction, the bottom of a fraction. They talk to you like you're 5. You were saying, I could literally go to my godson, who's 7, and go, Colin, what's this? Oh, it's the top of the fraction. This is the bottom. You all are not 7, though. And you all are very, very bright kids, but your teachers don't say things like, it's the numerator, it's the denominator. Under the value under, great, let's say this, when you have a square root, does anybody know the name of the value in column what's under the square root? And you got this, see why and I'm not mad at you, don't ever, I'm not mad at you. It's called, if there's a radical, what lives under the radical? The radicand, okay? We go in division, there's a quotient, the remainder from division. They always say remainder because that's easy to think of remainder that's left over. When you get to college, you go through and we call it the mantissa. You're going to learn so many years. Here's a wonderful one, and I bring it up because the other day, I drink a lot of Snapple and Diet Coke, and you'll hear them go off. Sorry, this was almost like a sign from above the other day that I got. There's a line there. And a fraction. There's a numerator and a denominator. That fraction actually has a name too. Any of you know what it is? Because there was one kid there were actually two kids in the first section that knew what it was called. And I'd write this down because this would make a fabulous extra credit question. It's called the vinculum. You will learn all sorts, and I asked if it actually was the sample factor today. Now, is that right? And by the way, there was one teacher that knew what it was. One. So that line between the top and the bottom of a fraction is the numerator and denominator. Now, when we're talking together as a group, you have to be careful with your language. You have to be careful with your language. Because as that last piece was said, they're technically, and if you were with me at U of R, we would not take that answer. Because what you said was p plus 2, which is fine, minus 3p plus 4. Did I go over what we need to say if we're talking about parentheses? Quantity of, right? And we'll get you, you're going to, listen. You can call me a crotchety old man, that's fine. I know I am. But the one thing, you all now have the privilege of having my name next to your transcript forever. I've had people come to me, I've had my own colleagues come to me when I'm at U of R. They go, I had one of your kids the other day in class. I'm like, wonderful. He's like, he was the only one who knew what the Radican was. I was like, okay. He's like, and this isn't U of R. This isn't like, no offense, this isn't, Genesee Community College or Everest Institute. This is a good school. None of your kids, and they're in an honors class. They don't even know what the value wanted. I'll correct as much language as we can. Get mad and don't take it personal. Because when people get to college and they start calling it, especially when it's AP Calc, when you say it, you don't get credit for it. And when you get to college, people actually are not, I guess, like, maybe their bullying training is a little bit lacking, but people laugh at you when you say the wrong thing in college and you get the wrong answer. I don't ever want you to have to go through that. We've had a nice safe environment here. When we do this out, make sure you say, if you've got parentheses there, they absolutely are made. Now, do I need to say the quantity of p plus 2? Do I need to say the quantity of p plus 2? No. Do I need to say the quantity 3p plus 4? Sure. Or I could also have said the next step, which is to take this one step further. I could, and you're fine to do it. What could I immediately jump to as my step 2? What's the next thing I would do once I got here? I hope all of you at least got to this point. What can we do to go forward? What are you going to say? And what are you going to have then? There you go. You can distribute that out. I'm fine with that. So now, hopefully, staring you in the face is what we would do next. What's our next step going to be? You know? Yeah, combine like terms. Same thing you did back in 7th and 8th grade. When I do this quantity over here, this whole mess over here is going to simplify down. Brackets, by the way, are just secondary parentheses. So that simplifies down. All of a sudden now, something should jump out at you. You're trying to factor this down, which means simplify it down into its component factors. I can keep going. Does anybody see what we can keep doing to go forward from here? I don't think it's that tough.
Distribute up to -2.
Careful, not distribute. Not just factor. See that -2 that's there? That's what you've got to see, and take out the -2. Now, here's the other thing that you've got to keep in mind. Does order matter with multiplication? Does the order matter in multiplication? 5 times 8 is the same as 8 times 5? Sure. The order doesn't matter at all. So, I hate leaving a monomial and then after 2 binomials. So we'll go through and list that out. I want you to take a look for a GCF. There's more than one right answer. A GCF in example 4. see if we can get 8 people that can tell me what one GCF that you could choose in example 4 would be. We got none so far. We got 1, 2. If you got 1, you're good. We got 1, 2, 3 of you now that can tell me what a GCF in example 4 is. 4? You could take out a negative A. What's the other choice, by the way, for a GCF? You could just do an A. Now, there's varying degrees of being correct. Why would I prefer you to take the negative A out as opposed to the A? No, I wouldn't say that, although that is true. Yeah, look at what's left over, because again, you're always going to be looking to keep going further. If there's a negative A squared here, this doesn't lend itself to factoring easy based off the patterns that you all know. This does. So that would be one way. That's why I'd like you to take out the negative A if you can. You're not wrong, though, to leave the A out. But just make sure, by the way, that the signs are going to change as well. You've got to factor the negative out from everything. So questions on that? Now, what we're going to do is, it's called factor by grouping, but what it essentially is a double and or triple GCF. Take a look at this, and it might be confusing in the beginning. So the first thing I'm going to ask you to do is just look at the first 2 terms and the second 2 terms. We're going to sort of divide it up. Look at the first 2 terms and the second 2 terms. And specifically, I'm going to look at the first 2 terms. Hands up, please, and tell me the GCF for the first 2 terms. We got 1 person, 2. What would you like? And what's left when you take out that A? Then the plus sign is there. Now look at the second 2 terms, please, and hands up if you can tell me what the second 2 terms have in common. We got 1, 2, 3 of you. What kind of B? A positive B or a negative B? Now, I get to here, and this should jump out at you and go, I'm not done yet. What more can you do? Who sees what we can do to work forward? You see it? What that? It's a GCF of x minus y, the quantity of. So let's factor out the quantity x minus y from the left and the right half. What's left? Hands up, please, and tell me what remains. What that second quantity is going to be, or what's left after I divide that out. Terrific. With that in mind, please go through right now and do example 6 on your own. Looking at the first 2, hands up, please, and tell me what the GCF from the first 2 will be. And what's left? Hands up, please, when you can tell me what the GCF from the second 2 is going to be. You want to take out a negative A. If you don't take out a negative A, that second binomial will not be the same as it was in the first. So I'm going to take out a negative A, and now I'm going to factor out again. For the third time, I'm going to take out a GCF of the quantity x minus y, and this is what we would get. Go through and do 7 right now, please. should be able to see the first one, the GCF is a 6x. What's the second GCF going to be?
1.
Yeah, positive 1. That's tough, because again, if we go through, there's this argument in math all the time where I'll minimize the significance of 1 as a factor, and then sometimes you need the 1 there. Like the example, I think it was, look at example 1 from page 1. Didn't I even have us write, like 1 isn't a common factor? Yeah, there's no other common factor than 1. So does 1 common factor? No. And then over here I'm going, well, is 1 a common factor? Yeah. It all depends on the context and what you're using it for. Now, the other thing that you have to keep in mind is, right now I've got a polynomial that I'm going to try to factor down. And when I'm factoring this down, right away I look at the first 2 terms and then the second 2 terms. Is there a GCF between the first 2 terms? Is there a GCF between these 2 terms right here? No. What about the next 2? Is there a GCF there? Maybe you can take out a negative 1, but that's it. So you think you're done. Does the order of those terms matter? So I'm going to keep the signs the same. I can put them in any order I want. Can I rearrange it so they have common factors with the first 2? Same thing, I can force there to be common factors with the second 2 if I go through and rearrange it. So I went through and rearranged it like this. I made that my first 2. I took the 10, threw it at the end, and then put the 2q squared. So I switched them around just a little bit. Because now I'm going to be able to factor something out and be left with the same remainder, I guess, on the left and the right. Look at those first 2 terms. Hands up, please, when you can tell me what you can factor out from those first 2 terms. Wow. What do you want to say? And what's left, please, when you take that out? How about from the second 2 terms? Hands up, please, if you can tell me what your GCF is. We'll wait for 6. We got 1, 2, 3, 4, 5. What do you say, please?
-5.
Careful. What did you say it was? Just a positive 5, yeah. That's going to leave me now with the same p squared minus 2, so I can factor that out. The GCF goes in front, the remainders go at the end. Questions on that? All right, now, here's some, and this is one thing again, sometimes you'll have homework assignments that are graded. I'm going to say this. I'd rather you give 55 minutes solid in here and maybe 10 minutes on homework, actual homework, not watching TV or texting or whatever it is, distracted homework. I'd rather you give me 55 and 10 than go through and be, staring at the ceiling in class, and fade in and out and give me 30 good minutes of class time and then, an hour of time doing homework in front of the television. So you've got to make sure that you're on task with it. This type of, and it may be different for some of you, I'm giving you literally 32 questions. And I'm telling you, do as much as you need to be successful. Those bottom ones down here, I'd look at question 29. So I start off with question 29. What type of factorization can I do to start off 29? Take a look at it. Who can tell me what we can do to factor down 29? So I go, oh, it's impossible. What do you want to say? You can factor out a GCF of 2z plus 1, and then keep going forward. By the way, if I have, which one was it? 29. Okay. Yeah, over here, you need to know how to do a question like 22, 24. You need to know how to do them. Sometimes the questions that you get on your assessment the next day will be those exact questions. So if you get them, you get a little bit of a reward. I'm not going to collect homework, though, all the time, because, again, you all cheat, copy. The whole plagiarism issue is sort of terrible. Now, what I'm going to have us do, we're going to bounce over, though, please, to page 6. Some of you at least said that you remember doing this from Algebra 1, which is what you took back in Sprott. When you do this, let's say this. Raise your hand if you can give me an example of a perfect square number. You can give me a number. Perfect square. 6. What's that?
36.
36 is a perfect square. Who's got another one? 4 is. Who's got another one?
16.
9. There you go. And you keep going. So we start off. You need to be able to recognize your perfect square. Perfect square is what you get when you take any number multiplied by itself. So 4, 9, 16, 25, 36, 36 and 49, 64. Next one up is 81, 100. 11 is 121, 144, 169, 196, 225, I think 256, and then we go on from there. Those are numbers that are triggers. The REACH gives you those numbers a lot of times. When you see a 25, you need to think that's a perfect square number. When you see 81, perfect square number. 36, same thing. When I do this, this is a difference of perfect squares. Difference means subtraction. Looking at this to start off, I'd say, well, this is a binomial, so that's a trigger that maybe this is a difference of perfect squares. Is there a GCF in A? Is there a GCF in A? So the next thing I want to try is the difference of perfect squares. I look at this and say, all right, I've got a left and a right term. There's subtraction between them. That's where the difference part of difference of perfect squares comes from. I'm going to take the square root of the left and the square root of the right, since both of these are perfect squares. The square root of the left is a t. The square root of the right is a 6. You're going to break this down. Does anybody remember how this factor pattern works or no? No? All right. You're going to take the square root of the left plus the square root of the right times the square root of the left minus the square root of the right. So this would break down into two binomials. The quantity t plus 6 times the quantity. There you go. Now this next one I love because some of you are so eager and you rush. You're going to want to say that's difference of squares right away, and I'm going to say you're wrong. I look at question B, I see something different. Who sees the first thing we should be able to do on B? We got 3. GCF. I'm going to take a 4 out from both terms. I'm not saying it can't be a difference of perfect squares. I'm saying there is a GCF to start with. And then what's left, that remaining binomial, is a squared minus 16. So I say, well, this is a here and 4 here. There's subtraction between them. So hands up, please, if you can tell me what your final answer for this is going to be. Go ahead.
4 divided a plus 4 and then times 20 and b minus 6.
Outstanding. That's terrific. Next one up isn't going to be as easy. That's a little bit of a push. Not nearly as much as those last two. No GCF here. The square root of the left is going to be 4m. The square root of the right is 7p. Hands up, please, if you can tell me what c would factor down to be. Follow the pattern. We'll wait for 5 of you. What c factor down to? We've got 1, thank you. 2, 3, thank you. Outstanding. Now the next one's just a little bit difficult, and this is again one of those questions that is a push and extension for you. I look at this and I say, all right, for D here, there's no GCF, so I look at this and say, well, wait a minute, 81k squared, that's going to become 9k. What's the square root of what's on the right? Hands up, please, if you can tell me. What's the square root of the right?
A plus 2.
The quantity a plus 2. Now, when we do that out, and the reason I say quantity is sometimes the parentheses will matter and sometimes it won't. This one, it matters partially. I'm going to look to factor this down. You can tell me what the first factor would become. Just follow the pattern. What do you think the first binomial would be? We say binomial, it's actually triangle. Go ahead. Not a2 plus a plus 2. The second part is going to be 9k minus the quantity a plus 2. Because I did the square root of the left plus, right? Why does this have no parentheses, but this one here does? Hands up, please, if you can tell me what.
Because the second one, it has a negative, and then like the first one is about hundreds.
You've got to remember, you need to distribute out a -1 to everything in that second set of values. So this can stay the same. This would not be an acceptable final answer. You'd be expected to go a step further. And how far can you go? That's what we would get. I've got one more that we're going to go through and do, and this is a good extension question. This is a difference of perfect squares. I'm going to take the square root of the left and the square root of the right. What's the square root of the left, though? Hands up, please, and tell me what the square root of x to the 4th is going to be. And this would be a 9. Keep going. Let's see how far you can take this. Doesn't turn. Good. How are you? Is it Kirsten Myers? Or Kirsten Myers? Yep. What room was it? Thank you very much. Hold on. E202 at the end of the period. Looking at this, I'm going to look to factor this down. The first breakdown should be easy. You can tell me what our first step is going to look like. We'll wait for 6 of you. We got 1, 2, 3, 4, 5. 1 second. That's outstanding. I'm not done yet, though. Why am I not done yet?
From the quantity of experiments
You can do difference of squares on the a squared plus 9. That's why, and by the way, another number that you can take the square root of twice is 16. Because what's the square root of 16? And the square root of that? There you go. All right, so I'd advise you. Now, there's a couple of ones down here. You could give these guys a try tonight as well. But what I'm going to ask you all to do is this. I need to make sure that I have which section are you guys? You're section 2, is that right? All right, so what we're going to have happen is this. When I talk about rows, so we're all on the same page, this is row 1, 2, 3, and 4. What we're going to have is, I'm going to call the first 2 rows up. You're going to tell me if your name is down. Did we do this already or no? Okay, this is pulled from the computer, but it was pulled a long time ago. You need to let me know, did I misspell your name? Is your name not on there? Is it right, wrong, whatever. And if your name on there is like, Gregory, and you go by Greg, let me know whatever you like to be called, okay? So what we're going to do, first 2 rows, come on up, get in a line up by the computer, and I'll tell you. Second 2 rows, you guys can put your calculators away, and then when you guys get done, you can come back. I'm going to call the next 2 rows up as this winds down. So first 2 rows, can you slide up, please?
Yeah, it's
Anthony.
so good.
This one, and you're good? You go by Anthony?
Yeah.
Anthony? Okay.
Tom Sorting.
Okay. You're good?
Yep.
Terrific.
Sam.
Samuel, okay.
I go by Sam.
Sam, thank you. And you go by John? Okay, thank you. Megan, where are you, honey? Do I have it down? Okay, and you're good?
Yeah.
Okay, great. And do I have you down here? Yep, is that good?
Yeah.
Thank you. Is that good? Okay, you go by Emily?
Yes.
Benjamin Brown.
Okay.
I go by Ben.
Ben? Okay, thank you.
Connor Lindsay. Looks good.
Connor, where are you? Right here? Good, thank you.
Sean.
Next 2 rows, come on up.
Sean Lynch.
Where are you, buddy? Oh, and that's good?
Yep.
Okay. Let me know if it's misspelled also.
Anthony Flora.
Can you go by Anthony?
I go by AJ.
AJ? That's right. I was told that. Thank you.
Sean Taylor.
And I have that right? Okay, good. Thank you.
Melissa Santiago.
Okay, is that right? Okay, thank you. Where are you, honey? Do I have it spelled right?
Yeah.
Okay, thank you. Smith, do I have that? Is that right? Okay, thank you. T, and that's right? Okay. And that's right? Thank you. Riley. Is that right? Okay, thank you.
And what's open? I go by Nick.
Nick. Thank you.
Thomas Wayne. I go by Tommy.
Are you related to Ryan? Okay.
Corey Spooner.
Spooner. And that's good? Thank you. So this one, is that right?
Yeah.
Okay.
Kristen Myers, and it's right.
Okay. I'm going to apologize now. You get people call you Kristen all the time.
Kristen Pearson.
Do you hate people that call you Kristen? I'm going to screw up. I know
It's
I
okay. I
Just
respond to anything.
don't visually stab me, okay? The first time, all right?
Nicolina Zapata, but I go by Mickey.
Okay, where are you, honey? This one right here?
Yeah.
So how do you spell that?
MICKY.
Amanda, where are you, honey? Right here? And you go by Amanda? Okay.
Grace Parmalee.
And you go by Grace? That's good? Okay, thank you. By the way, kids, who in here was able to get their Math Excel signed up from the other day? It's fabulous. What's going to happen is over the weekend, I'm going to assign you just the orientation chapter, which shows you, literally the questions are, the number 5 is here, type in the number 5. Okay? And it's just so you know how to input your answers, because with negatives and math answers, it can be awkward at times. Have a great weekend.
We have that tomorrow.